So here we are with another question related to sinusoidal signals. Here it has been asked to check whether the sinusoidal signal xt equals to sine 12 pi t is periodic or not, and if it is, to find its time period, the fundamental time period. Okay, so first, checking the requirement of periodicity, for periodic signals, it has to satisfy this condition. Okay, here xt is equal to sine 12 pi t, equation 1. Now x t plus capital T is equal to sine 12 pi t plus t, which is equal to sine 12 pi t plus 12 pi capital T. So here let it be equation 2. So here, for this condition of periodic signals to be satisfied, these two equations must be equal. Okay, and for that to happen, here in sine 12 pi t plus 12 pi t, here this portion 12 pi capital T, it should be an even multiple of pi. Okay, because we know sine 2 pi plus theta is equal to, where theta is an acute angle, is equal to sine theta. Like we have did in the previous question also, it is the same. So here this 12 pi t, this portion, when it becomes some multiple of 2 and pi, then we have sine 2 and pi plus 12 pi t, which is equal to sine 12 pi small t. So here that implies capital T equals to 2 and pi by 12 pi, pi cancel, 6, that is equal to n by 6 seconds. Okay, the general expression n by 6 seconds. When we take the smallest possible value for n equals to 1, the fundamental time period becomes 1 by 6 seconds. Okay, so here the fundamental time period is 1 by 6 seconds, and the general expression is t equals to n by 6, this. Okay. Hello friends, so here we are with another question on periodic and non-periodic signals, that discussion. So it has been asked to see if the signal xt equals to sine pi t multiplied with the unit step signal ut, it is periodic or not. Okay, so first we have the signal xt equals to sine pi t. Okay, let's call it x1t. Okay, so we know that in general a signal of the form sine omega t, it is periodic with the time period equals to 2 pi by omega. So here this signal is periodic. Okay, x1t, only this part, it is periodic with time period equals to 2 pi by pi, because omega here is equal to pi, that is equal to 2 seconds. So it will be something like this. Okay, it is slightly high. Okay, this 1 minus 1, and the period, the fundamental period is equal to 2 seconds. Okay, that is equal to 2 seconds. Now we have the unit step signal, which is this, exists only for the positive time. It is a causal signal. Okay, the unit step signal. The product of these two, now here for unit step signal there is nothing like what is the period. It is not periodic because it goes on indefinitely for the entire positive duration from t to equals to 0 to t to infinity. So it does not repeat itself. There is no pattern, no such pattern which repeats itself. Okay, so if it would have been something like this, see, if it would have been something like this, then it comes 0, like this, then it would have been a square wave. Here there is a particular pattern which is getting repeated. This is the pattern. This is the pattern which is getting repeated. Something that in the basic requirement of a periodic signal is that a fixed pattern is repeated at regular intervals of time. Okay, it gets repeated. But here there is no such thing. In case of unit step signal, it goes on indefinitely from 0 to infinity. So this is not periodic. It is not periodic. So when we multiply this with this, okay, unit step signal with this one, there is nothing out there in the negative time here for the sinusoidal signal. For the sinusoidal signal, there is nothing in the negative time duration, that is for t lesser than 0. It would be something like this, only for the positive time. Like this, and this one will be 0 because the unit step, it is 0 for t lesser than 0. So the resultant signal will be non-periodic, it will be not periodic. So here the product of x1t sin pi t and x2t equals to ut, this product is non-periodic. Okay, so here the resultant signal is non-periodic. Okay, here it is completely 0 in the negative time interval, and in the positive time duration it is the basic sinusoidal signal. Okay, so the resultant signal, this resultant signal is non-periodic. Now here another interesting thing, suppose it would have been something like this. Let's say we have a signal like this. Suppose it is like this. Here it is 0 for a particular period of time, then it is sinusoidal. Then it is 0 for a particular period of time, then it is sinusoidal. Then it is 0 for a particular period of time, then it is sinusoidal. Then this is a periodic signal with the total period from this point to this point, this. Okay, and this is the particular pattern which is getting repeated. This pattern gets repeated on and on and on, and this is the periodic signal. This is a periodic signal. But here it is not. No such pattern is repeated. For the negative time interval, it is totally 0. For the positive time interval, it goes on indefinitely, the sinusoidal pattern. So no pattern is repeated, nothing is repeated. So it is not a periodic signal. This is a periodic signal, but not this. Okay.